Scientific research is undertaken in universities, in public research institutes, charitable organisations, and within industry, with the majority carried out in the latter in commercial companies. Research is an important input to innovation, and not just in delivering scientific discoveries, but also research that identifies market gaps and hence innovative opportunities. Research generating either science or market discoveries then delivers innovation through the intermediary of invention, as products, services, and processes meeting a market need. The productivity of research, the cost effectiveness of delivering science and market discoveries, will therefore impact on innovation. Conventional thinking from OECD countries focuses on the input of scientific research and argues that by investing more in scientific research in percentage terms of GDP, it will generate more discoveries, which in turn through innovation will impact on economic growth. That is, GDP is dependent upon the number of researchers and their individual productivity. This economic model has dominated research funding for a century, but it only works if research productivity increases or at least remains constant per researcher. So the question is, does research productivity remain constant so that increasing the number of researchers and hence research input costs increases innovation and economic growth? Guess what? It doesn't. And it hasn't. And we are actually facing a rising decline in research productivity, and yet nobody seems to have noticed. Well, that's not wholly true. Empirical evidence and the excellent work of Nicholas Bloom and his colleagues investigated in 2020 the importance of research productivity at three different levels: at the aggregate, industrial sector, and at an individual company level. Their results across all three levels were quite startling because at every level they found significant evidence of a decline in researcher productivity. The analysis of this is given in detail in the second volume of my book, but all three levels, while the percentage of research effort had increased, the research productivity had declined by even greater amounts. But why should research productivity decline? The key here relates to creative and novel aspects of research and the evolution of scientific processes over time and the measures used to determine performance. Firstly, the reductionist approach to research and increasing specialization has led to an increasing knowledge burden that can only be managed through increased collaboration. And collaboration, especially in large programs, reduces novelty and contributes only incrementally to innovation. Secondly, the increasingly reductionist approach by specialists has led to an increasing distance from real-world problems and creates an expanding divide between discovery on the one hand and translation on the other. Thirdly, a lack of creativity in education systems generates conformist researchers who are risk-averse as reviewers of publications and grant-awarding panels, and who conform and support paradigms that should be challenged to progress science and innovation. Finally, the emphasis on research excellence means that researchers are motivated by options that further their career, prioritizing research publications over patents and other means of generating impact, encouraging hidden innovation. Combined, this provides a heady mix that is detrimental to research productivity with the ability to innovate that subsequently impacts on economic